All right. In these two situations, okay, situation A, massless pulley. Situation B, pulley with mass. In situation A, what is true about T1 and T2? They're equals. Everybody cool with that?
Uh-huh.
Do you understand why? Because it's a string. it pulls on both ends. Now, situation B, the pulley has mass. Are T1 and T2 equal?
No.
Okay, good. Everybody realizes that, yes? T1 and T2 are not equal, good. So in that case, I gotta make sure I'm distinct in these two things. So I say T1 is equal to M1A, and then I can say the sum of the forces in the Y are equal to 0, so Fn is equal to F1G. Does this matter? No. Why not? Why do you say no, Eric?
It's in the, for T1, it's in the
It could, though. It could. This could make a difference, but in this problem, it does not. Why? Yes, there's no friction. Do you see what I'm doing there? This would only matter if there was friction, because then Fn would be a function of friction, which would then cause a force to the left. Okay? All right, so our statements are fine there. This doesn't matter. Who cares? Now I'll go to, I don't want to use yellow. I'll do these two torques in green. And then I'll say the sum of the torques is going to be equal to I alpha. Now, is everyone here aware that the alpha is the same, like alpha times the radius will be the same as the acceleration for the other two things? Because even though the tensions are not the same, the accelerations have to be the same, because we're assuming that this string is non-elastic, right? It's a I can't say rigid, but whatever. It's a non-elastic string, so it's not going to stretch. It's going to be consistent. So then here I can say torque 2 minus torque 1 is going to equal I alpha. Any questions from that? Concerns? All right. So then I will use, for this one, I'll use this sort of pinky stuff. I don't know. And we'll say the sum of the forces in the Y are equal to M2A. And then so I get M2G minus T2 equals M2A.
Why are you torque 2 positive?
Because I'm assuming it's going to go down.
Because it's the second box and now it's going clockwise.
Exactly.
But isn't that on the first? Okay.
Cool. Good, good, good. I like it. Ponder, think, ask. Questions? All right.
So,
Yes.
This one, kind of like on the one that's like came like from like off the side of the table, then and like Fy equals M2A, and then like because it's kind of like the X, except for the fact that in this case it's vertical and not horizontal.
Yeah. Now here, this is the foundation of everything. The torque statement, because we're going to solve this and sub it in, take this and sub it in, and then solve everything. Looking for the acceleration, right? And that's what we would do. Everybody cool with that? You see what we're doing? Okay. So I guess if I go back to here, I would say T2 is equal to M2G minus M2A. And now if I go to white, I can sub everything in. So I get M2G minus M2A minus M1A equals 1/2 MP R squared A over R. And now I can solve for A.
Wait,
No, I can't. I can factor out A. That's not possible. What's going on?
wait, what just happened?
Something bad happened.
You can't factor out A.
Oh, I can't. Yes. Okay. Well, no, I can, right?
No.
No, there's a G. Whew. Yes. Okay, good. Whew. I was saved by my bad perception. Whew. You see what I mean? I looked and I saw all these A's, and I was like, oh, crap. Every term has an A. It cancels. But it doesn't. I just saw that incorrectly. This one saves us because there's a G term there. Okay? And that's important because then that means we move all the A terms onto the same side, factor out the A, and solve. Jace? Okay, now, if you take a look at this, if this pulley has no mass, right, then there is no middle term. It doesn't matter. All that matters are the top term and the bottom term. And the t is the same. Does this make sense to you? Because, I mean, think about it here. If this pulley has no mass, what is the moment of inertia? 0. So then these two equals 0, which means T2 equals T1. We're done. See? So all we have to do, if there's no mass in the pulley for part A, we take M1A and plug it in to here. Because we had M2G minus T equals M2A. So then our statement, and I'll go ahead and do this in like a nice powder blue, for no MP, our statement becomes M2G minus M1A equals M2A. And then we can simply say A is equal to M2G over M1 plus M2. Right? So that one's easy.
Your T2 is torque 2, right?
That is correct. So you see the difference there? By having a massless pulley, I becomes 0, which means T2 equals T1, which means I can just say I can just say T, and that means I substitute in this M1A here. I get this statement, solve for A, boom, easy. Now with a mass, it's not that much worse. I just have to have this 1/2 MP, blah, 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 this thing over here, and then now I just have to solve for A, and we'll be good. Finished. That problem. Okay, so that means